All right. Well, welcome. This is our webinar series, WebAge Speaks, and today we're talking about what's new in Java 8, and just kind of lay out what are the major changes and kind of some of the things we see happening in the Java space, I think, nowadays. You might ask the question, well, why are we talking about it now? Because Java 8's really been around for a couple of years, and really it was a couple of years ago that Oracle did their big Java 8 launch and reveal and everything. The reality is it takes a while for people to start using an environment that's compatible with new release of anything, and we're finally starting to see that. And we'll talk about that a little bit during the webinar as well. So we'll talk about that. First of all, my name is Stuart Smith. I'm the Java Administration Lead for WebAge, and we have a wide selection of Java and Java Enterprise programming and administration courses. So we'll talk about that. Towards the end, we'll kind of talk about what we have to offer in terms of Java courses and kind of what we're doing as far as the plan for releasing some of those courses on Java 8. So we'll talk about that just a little bit towards the end. And we also have a virtual class that's coming up that focuses specifically on what's new in Java 8. So I'll have some details about that if you're interested in that as well. So what we'll do in the talk is kind of a quick recap of recent history of Java, and really we are going to go back to Java 5 a little bit, just because in my opinion Java 5 is really the last time that Java had a release as big as Java 8 is. I think Java 8, for what it does, is probably bigger than Java 5, probably has a lot more different impacts, but 6 and 7, there were certainly some changes introduced, but it wasn't quite as broad reaching, I think, as Java 5 and Java 8. So we'll just kind of take a recap of where things have gone and how we got to this point. Then we'll go through some of the key Java SE8 changes. No way to really go through all of these in a short period of time. We're going to focus on probably the changes that have the most impact on what you're going to do as far as Java programming, so we'll try and keep an idea of that. Again, we'll do our offerings as well and just kind of run through that. Depending on the time, I have a section for some of the changes in Java SE7. We had that in a webinar a couple years ago. Really what I did is I just moved it to the end. It'll probably end up being just left as a reference. So that way when you guys download this presentation after, and again, just keep an eye out for the follow-up email, and that should have some information about where to get the webinar presentation. You'll have that kind of as a bonus reference section towards the end, but I included the Java SE7 changes. And we'll take maybe a quick glance if we have time, or some questions, but probably I imagine that's probably going to end up being a reference. So we want to focus most of our time on Java SE8. Of course, that's the thing that's newest to most people. All right. So kind of recent history of Java. Again, a really quick recap, right? Remember way back with Sun, right? Sun hasn't been around in a while, but a lot of the early history of Java certainly wrapped up in Sun, of course. It was actually back in 2004 that we got Java SE5, right? Java SE5, like I say, is probably the last really big change in Java in terms of some of the impacts it had. So we got there with enumerations, we got generics, generic qualifiers, enhanced for loops, for each going through a collection, and also annotations. And annotations is kind of a minor thing in terms of the language, but it's a huge thing in terms of what a lot of other APIs can do in terms of what's available. So a lot of big changes in Java 5, so that's why I wanted to kind of start with that and see where we come from since then. A couple years later, December 2006, you have Java SE6. Not really a whole lot of major changes. Probably one of the most significant changes that I saw was they kind of moved where the web service support was. It used to be that a lot of the web service API support was only in Java Enterprise, and you didn't have anything in Java SE. They moved some of that down into Java SE, so you had some of that API available for standalone web service clients, of course. Right? Because to be a client of a web service, especially, we don't have to be running on a server ourselves. It might be a standalone Java application that's a client of a web service. So that was a little bit bigger change, but again, that's pretty focused and not really a broad change, perhaps. Sun was always a little bit reluctant to move to more of an open source model, and of course the community was really kind of fighting them with that and hammering them with that. They eventually did basically come to an open source model. It was almost too little too late to to save Sun as a company or anything, Because what happens is Oracle comes in, right? Basically buys Sun in 2009, right? Sun was kind of in a weaker position. They were kind of shopping around a little bit, looking for another company to buy them up, basically. And eventually, there was open source Java. There were still disagreements with, what was part of that. What was part of that open source? What control did Sun really still retain? A lot of those divisions are really still there, but I think once Oracle came in, everybody said, well, you know what, we're not going to get it to change. Right? We're just going to have to go with where it is, and just kind of accept what's happening now with Oracle. Right? Because Sun was kind of shopping around and looking for someone to buy them as a company, of course, Oracle, when it takes on a major company like Sun, there's going to be a certain transition period. The reality is that there was a quite large gap between Java SE 6 and Java SE 7. Right? During that time, it's not like Java innovation had stopped. A lot of the new features that were being proposed for Java, a lot of the new features being proposed for Java were part of the kind of official OpenJDK, open source implementation, basically. So there were a lot of ideas coming out, but there was not an official release. There's not a release that says this is exactly what the next version of Java is going to be. This slowdown in the release of Java SE specifications also slowed down Java Enterprise somewhat, because Java Enterprise typically requires a certain level of Java SE. And it's just happened that they've been kind of lined up. Every time there's a new Java SE release, well, not long after there's a new Java EE release as well. Doesn't necessarily have to be that way, right? But that's just kind of the way that things have happened. So it kind of slowed down the Java EE specifications a little bit as well, right? Oracle decided to split up these new features that were kind of being collected in the OpenJDK project. And the idea was, well, we'll take some of the easier ones, quote unquote easier ones, in Java SE 7 and just kind of get those out there and get people used to them. Now let's keep working on some of the other ones, right? So some of the other ones would be later in Java SE 8. Like it says here, we've actually come up, it's about 2 years now since Java SE 8 was released, right? And the good thing is, we're now moving forward again. We're getting more regular releases of Java SE, getting some releases of Java Enterprise as well. So we're kind of moving forward again, kind of more unified community, stronger company, kind of as a steward of Java, basically. All right. So now that we're moving forward, kind of what's out there right now, right? And really, it depends on kind of what project you're working on, definitely, because of course it's always about support. It's about if I have problems with the environment, am I going to have something that I can go to someone and say, hey, I'm having a problem. Help me fix it, something like that. For standalone non-server Java projects, right? Something that's not a Java Enterprise application. Java SE 7, I think, is still the default, but I think Java 8 is definitely starting to gain more ground, right? Mainly because you don't have to wait on an enterprise server to release support for it. You just need support for it. Just need to use it, right? So I think more and more people are beginning to do that, right? Java SE 8 has been slower for Java Enterprise projects, of course, because the ability to use Java SE 8 is not really under your control. It's basically a choice of which application server we're using, and does that application server, that Java Enterprise application server, does it support using Java SE 8? Right? I think this bullet here is pretty good, pretty good sign, basically. It's taken a little while for application servers to release support for Java EE 7, and because Java SE 8 has been out there for a couple of years, they're saying, you know what, let's release our Java EE 7 application servers with support for Java SE 8. Right? They don't necessarily have to. Right? The only level of Java SE that they have to support is they have to support Java SE 7 with Java EE 7. But they're saying, you know what, let's go ahead and do it. Let's go ahead and release support with Java SE 8. Right? And I think that pattern will hold. Right? The more application servers that get on the list of compatible Java EE 7 implementations, they're going to have Java SE 8 at least as an option for what version of Java you can basically use. Right? Now, even if you're not running a Java EE 7 server, if you're using a Java EE6 server, so again, you have to be a little bit careful about kind of what version you're talking about, but even with a Java EE6 server, right, it may be possible to use Java SE8, right? And that's really what kind of changed my mind in terms of when is this going to be important, right? Is in my mind it was kind of, well, it's going to be a lot more important when the major application servers are going to release support for it. And kind of my assumption was, well, it's going to wait until the next version of those servers, the next major version. But what a lot of the servers are doing, pretty much all the major application servers are doing, is they're saying, you know what, if you're running some of the latest updates, and these are some of the versions out there for things like WebSphere, JBoss, and WebLogic, if you're running at least these versions, we'll support you running that on Java SE8, right? So it is possible now to have a Java Enterprise 6 server running a Java SE8 foundation, if you will. So that is possible. Certainly a little work you have to do to get to that point. You know, you have to be on one of these major fix packs, some of these which are pretty recent, right? So you have to make sure that you're running on one of those. Have to be making sure that you're compiling and checking your code, of course, against the new version of Java. Remember, a lot of these Java EE6 servers, well, they first released with Java SE6. Right, so this is really a couple versions of Java that you can now upgrade underneath the covers of a Java EE6 server. And a lot of clients, you know, you kind of decide on your own, is that something you want to do or not? You know, maybe we want to wait until the next, you know, major server if we're already doing an upgrade to go from, say, WebSphere 8.5 to whatever the next, you know, WebSphere version is or whatever. Why don't we upgrade the Java version at that point as well? Right, so you could certainly wait for that. It's really just an internal decision, you know, based on what you guys want to do. But the big thing is that it is possible, right? Up until this point, it really has not been possible with the major application servers, and now it's possible. And like I said, that changed my mind a little bit about when this is going to become important. I didn't think we'd get Java SE8 support on Java SE6, Java Enterprise 6 servers, right? But that's what's happened, and that's where we're at basically right now. All right. And one thing I like to do is just to kind of collect some more information from you guys about kind of, you know, what you guys are doing and that kind of thing. Have a couple of poll questions, and I'll open a poll question kind of between the sections if you want. Generally use these poll questions just to get some more background information from kind of where you guys are coming from. It helps us kind of tailor, you know, what technologies we're focusing on, not only with webinars but also training classes and that kind of thing, right? So it helps just to see, you know, this question, you know, kind of your experience with Java SE8. So if you're using Java SE8 now at all or not. All right. So for once I shut down the poll, I can't really reopen it. So go ahead and jump in and put your vote in on the question there for a second. I'll go ahead and close it. Right now, pretty much just what I expected. You know, most people right now, not at all. Little bit. Yes, only on some projects, right? Interesting, there's a small percentage of people say, yeah, it's our new default, right? Which is good, which is, again, kind of what I expected. You know, we're kind of seeing it a little bit here and there, right? But most people haven't really gone to it yet. All right, good. Well, it looks like we had 90% voted, so I'm going to go ahead and close that. I'll go ahead and share it real quick so you guys can see the results. All right. Like I say, just like I expected, you know, 7% not using Java 8 at all. Right, 23% on some projects, and again, 7%, and a little bit more than maybe I expected, but good. You know, default for new projects. All right, so that's good. All right, so let me go ahead and hide that. I'll go back to the presentation. All right, and I'll have one more of that, just kind of getting from you guys kind of what Java Enterprise application servers you're working on. Again, that helps us to kind of time, you know, what stuff are we going to focus on as it comes out, right, and that kind of thing. So this section, you know, probably the core of the webinar, key Java 8 changes. All right, so we'll go through some of these different changes, and some of them lambdas. Right, you hear anything about Java 8, you hear lambda, 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 right? And that's basically all you hear. And in fact, I kind of reviewed some of the Java 8 launch stuff that Oracle had a couple of years ago when they first, you know, released Java 8, and that was, you know, what it was. There was tons of stuff on lambdas, and a little hard to actually find stuff that wasn't focused on lambdas, right? So what are lambdas? Lambdas are probably the biggest change to Java SE8, definitely, and there's a lot of different impacts. Right? There's a lot of different places where Lambda expressions are really being used. And that's why I say, I think why Java SE8 is probably the biggest ever change in Java, right? Definitely the biggest since Java 5 at least, because we have this major feature in Lambda expressions that has a big impact on probably just about everything you might do in Java. Right? Certainly a lot of things you might do in Java. Right? It's not just like one new update to one little API that you may or may not use, something like that. It's got its hands in a lot of stuff that you can do. So a Lambda expression really is a function as a first-class object. Right? It's something we can now pass in as a parameter. It's an expression that we can actually declare as like a variable, so we can reuse those Lambda expressions. So we'll see a lot of cases like this. But Lambdas allow those functions to be treated as an object, right, and actually stored as data. Right? In the past, it was just pure state. Right? But now we're actually seeing functionality being treated as an object that we can pass around. One of the probably the default examples of how do we use Lambda expressions. It's not the only thing you can use Lambda expressions, but one of the default examples of how to use Lambda expressions is to replace anonymous inner classes. And we'll kind of run through that a little bit. Here it talks about implementing functional interfaces. Well, functional interface is an interface that has only one method. Right? And the idea is the only reason that interface exists is to define, hey, if you want to be like a comparable thing, we have to implement the compare to method. Right? So that's a great use of a Lambda expression, because really all I need is what do I want to run as the implementation of that compare to method. Right? That's really all I need for the implementation of that. So the example right here, you see an example of a Lambda expression. The key here in the Lambda expression, and it's really one thing you're always going to look for to tell if you're in an expression or not, this arrow. Right? So that's two characters, that's a dash and a greater sign. Right? That's an arrow that indicates this is a Lambda expression. Right? That's one thing you can always look for and tell, hey, is this a Lambda expression or not? Look for that arrow. Right? You'll always see that arrow in a Lambda expression. All right, whoops, let me erase my drawings there. All right, so as an example, kind of step through it, and I might switch over to some other code as well, just to give you a second example also. I'll kind of see an example of the compare interface, the comparator interface, right? So we'll see a Lambda as an example of that. And then we might switch over to some sample code just to see a second example. It definitely helps to see a couple of these to really get familiar with, what are we talking about in terms of, what is a Lambda expression. All right. So first example, we'll take the sort method of the collections class, right? Basically, it's going to take a collection, but it's also going to take, an expression, basically an implementation of the comparator interface to tell why is there, what am I going to use to sort things? Right? How am I going to tell, if I'm sorting things, how am I going to tell what's coming first? What's coming first, what's in second, right? So that's what we have basically with this comparator interface, is we have to have a implementation, right? There's an implementation basically that we need to provide an implementation of this compare method, right? And notice the compare method takes two arguments, takes the two things that we are comparing, and returns an int. And when that int is supposed to signify, basically, which comes first, right? So depending on the sign of that value coming back, determine, is arg0 first or arg1 first. All right, so that's what we have. So we need to provide some kind of implementation to that interface. All right, so what we're going to see here is how would we have done this before Lambda expressions, and then how are we going to do it with Lambda expressions. All right. Let me see. There are a couple questions that have come in. Right. Let me see if I can address those real quick. Again, I may not be able to keep up with all questions. Right. Somebody asked, is this like a block structure? Had back and small talk, used a lot in collections. Not sure. I'm not as familiar with what you're mentioning, so I'm not sure if that is the case. Then somebody asked, why is there no Lambda in the Lambda expression? Probably just because in terms of the char set of a keyboard, right? It'd be pretty tough to do that, right? So they're called Lambda expressions. Like you said, there's not actually a Lambda in the actual expression, right? But probably that's for for care set, I would say. All right. So in our example, before we did Lambda expressions, right? This would be our implementation. Right? We basically have this list. And I'll try and use the pen. The pen might be a little bit more focused. So here, this is our list of objects, right? That we are basically going to sort. And notice this is the first parameter into that sort method on the collections class. Notice the second parameter. The second parameter, we need to pass in, again, an implementation of that comparator interface, right? Well, one way we can do this before Lambda expressions was an anonymous inner class, right? So the syntax here gets really tricky, and it's really tough to kind of describe this to somebody who's new to Java, right? But notice this comma here is the separator between the method parameters of the sort method, right? This parenthesis way down at the end is the end of those parameters. So everything else that comes in between is something we're passing in as a parameter to the method. Well, what is it that we're passing in to the parameter as a parameter to the method? We're passing in a new object, which is a new comparator implementation. It's going to compare people, going to compare person objects basically, and we need to override that compare method. Right? So public int compare, and then all the brackets. The brackets are really get confusing. That's probably the worst thing about an anonymous inner class is all the brackets are running around. Right? So we need to provide something like that to define this implementation. Right? What I have in bold here, right? What I have in bold here, let me erase everything else, is really the core of the method. Right? Because really the core of the method is what kind of things am I going to be comparing, and what's the actual implementation code of how I'm going to compare them. Right? Notice in this case we're going to get the name of each person object and compare that. So maybe we're going to do it alphabetical by name. Right? And that's how we're going to sort stuff. And that's up to us to decide how is stuff going to be sorted. So that's a really core part of this is how is stuff going to be compared. But all of this other stuff, right? So let me go ahead and erase everything else. All of this other stuff, all the new comparator, the declaration of the method, and all this stuff up here, and these brackets down here, right? That's just syntax. That's just the syntax we need to use an anonymous inner class, right? Wouldn't it be nice if we could have something simpler that was just the core of what's in bold, right? And that's all we really had to code as we pass in this as a parameter. Just focused on just this part, which is really the core of our logic of how we're going to compare this stuff, right? One of the other things that's true about anonymous inner classes, right? Certainly it would be possible to declare a standalone class for, here's how we're going to compare people and run compare to. But that ends up generating a lot of extra classes that maybe that class really only has one place it's being used. So rather than having all these extra classes running around, we're kind of declaring that as needed when we need to define, hey, how are we going to compare to person objects and sort them using compare to. All right. So that's what we have here. All right, so let me go ahead and go to the next thing. So if you take a look at what happens when we use a Lambda expression, right, this becomes so much simpler. Right? It becomes just so much simpler. What we can do, and again, look at the characters here. Right? The characters here is basically what you have here. Right? This is declaring the Lambda expression. Again, the key to declaring the Lambda expression. Again, notice that we have the comma, which is, again, the comma before the second parameter of the sort method. Here's the end of that sort method. Notice no extra brackets, no extra new comparator and override the comparator. It's just the core of that bold code that we had before, which was how are we going to compare these two things. All right. Notice also the declaration of basically the method parameters. And notice we don't even need the types of the parameters because the types of those parameters can be inferred. Right? We kind of know what kind of things those are. Those are two-person objects. Right? So basically, if we have two-person objects being passed in as parameters, we can use them in this expression. Say, well, hey, get the name, compare the name to the name of the other one, and return whatever comes back from that. Again, the same core logic of what our code was before. But we've kind of stripped away all of the other anonymous interclass stuff. All right. So that's the idea. Let me go through the questions. Somebody just said that verified that the block, basically in Smalltalk, was what they were saying with Lambda. All right. And here are they inferred from the collections, declarations, definitions. All right. They are. So basically, we're inferring these are going to be two person objects, basically because the list that's being passed in, right? This list has a qualification of person objects. So if you're going to pass in a comparator for this sort, well, it needs to be a comparator that can sort person objects, right? So that's why we can leave off the, let me go ahead and erase that. That's why we can leave off the types of these parameters and just give them names in Lambda expression, because the types can be inferred, right, from the definition of, in this case, the comparator interface that we need to do the sort method. All right. So much simpler. Right? No extra, double sets of curly brackets running around for anonymous interclass. We don't need to have that new keyword that's always really weird. Why are we throwing a new keyword in the middle of that? Well, it's declaring a new instance of this class we're defining on the fly, right? So a lot more, basically a lot more succinct. All right. All right, well, good. Keep going. Like I say, I'll try and keep up with questions. I know there's a couple things. You just have to keep going. Let me erase stuff here. All right. So Lambda expression, right? That's the essence of Lambda expression. Basically strips down to the core of that functionality. Again, not the only thing you can use Lambda expressions for, but a really great example. Because the whole idea is we need to have this kind of on-the-fly definition of, in this case, how we're going to compare two objects, right? It needs to be done still on the fly. It's not as good to break it out as a separate class, but we want to simplify the syntax of doing that. Right? So something like that. The other thing we're also not showing here is you can actually declare this Lambda expression as a variable. Right? I can actually declare this as a variable that I can use and then just pass in that variable. Right, again, not a separate class, right, so I don't need a whole class definition, but again, on the fly, hey, this is my function I'm going to define, or this is my test I'm going to run to decide whether or not something is the same. Right? So I can declare these things, use Lambda expressions, and store those Lambda expressions as variables, as an object in that variable, and then pass that object in that variable into a method parameter. Right, so it's simplify this even further. All right. Somebody mentioned, looks like C++ macros. Not sure. Not as familiar with that. That certainly could be possible as well. I think the reality is that this feature in Java, really it's been desired for a long time. We're just finally getting it. It is drawing from a lot of other languages, some of the stuff that's been done in other languages. So if you do see kind of, something similar from other languages, I wouldn't be surprised if it is. Right? All right. One other thing that we can do with Lambda expressions is something called a method reference, right? Certainly you can see in this Lambda expression, let me go back to our example, this one is pretty easy, right? Because it's pretty easy because we have just a single statement that can return the value, right? Compared to P1, P2, compare the name, and that's all we need. What if there's a more complex process involved in implementing, in this case, this comparator interface? Right? You can define a Lambda expression that has a set of statements, and you could have a set of curly brackets in there to define those set of statements. But a lot of times it's a little bit easier to maybe have that as a separate method. Say, you know what, let me actually just define a method somewhere, right, that does the same thing. Right? And the big thing is that because it's a separate method, it's a little easier to write several statements and in the implementation of that method. So what you can do with Java 8 is now I can use a method reference. Right? Notice the key thing about the method reference is the double colon between the variable or class name, which is in the beginning that we're referring to, and the method that's part of that class or object. Right? So in this case, it's my compare. So if I had elsewhere in this class So my compare method that still implemented the same thing. It returned an int, right? It took two person objects as parameters and returned an int. Right? I can have some more complex logic, which is here, to basically implement that method. Right? Again, not quite an inner class. We're not actually coming out with a class definition. Right? But we're saying, you know what, I just need this method. And I just need to kind of break it out as a separate method, mainly just to simplify, how I refer to it up here. Right? So not only is it simplifying how I, pass in as a parameter, it's also making it a little bit more reusable. And maybe there are several places that I want to have this, compare method that I can use. So several different things. And notice the name of the method can be anything, right? As long as the signature matches what you need. Right? In this case, the signature is we need something that's going to take two parameters for person objects and return an int. Right? So no matter what the name of the method is, as long as it matches those requirements, right, then we can go ahead and use a method reference. All right. Like I say, big thing, several statements required to implement what a Lambda expression might do, basically. All right. So again, we're trying to kind of hit the high points here with a lot of the changes. Don't want to spend too much time on lambdas, but one thing we will see is Lambda expressions will make a lot of other changes that we'll go about. I think I'm going to leave that as the only example we go through. Again, I have some other source code I could go through, but I want to make sure we get through the other stuff. Don't spend too much time just talking about lambdas. Certainly lots of information out there. But what I'd like to do is focus on some of the other areas that Lambda expressions really impact. Right? And really, what are some of the things that Lambda expressions are going to allow you to do that have been added in Java SE8? Right? One of the things that I really wanted to add to this webinar was something about collection stream API. Right? A lot of times we're doing some operations, bulk operations, on a set of data. Right? Some always been kind of difficult to program. Right? And just as an example, just one example, the requirement of, well, we have a list of people. We want to print the name of all people that are over 45, they're male, and they live in California. Right? So very common to have some kind of requirement like that, where you have, I have a couple conditions, a couple criteria I need to apply to find out the people that match, and then do something with those people that match, and something like that. If we did this before Java 8, right, we'd have to manually iterate over the collection, right, come up with a fairly complex expression perhaps to determine, well, what matches. Right? Certainly not impossible. We see the example here, it's not impossible. But I think what will be really different is when you talk about what's even more complex than that. Printing the name is pretty easy. Right? What about more complex operations? So we'll talk about that. So let's talk about how do we do this before Java 8, and how would you do it with this collection stream API in Java 8. Right? So prior to Java 8, this is the code that you would have. Right? You basically have a for loop, right, that goes over the list of people. And again, this is the assumption this is a list of people, of person objects. So I'm iterating over each one of those and getting an individual person object, right? And then doing something with it. Notice this is our fairly long condition that we're looking for. We're looking for the age greater than 45, the gender is male, state is equal to California. So if it matches all of those criteria, then go ahead and print the name. Right? So that's what we're doing. So we're breaking that down, again, this if statement, and then an action we want to take. Right? Not too bad, but right now we're doing something pretty simple. We're just printing the name. What if it was more complex? What about calculating the average age instead of just printing the name? How do we have to do that? We'll have to add in a parameter or add in a variable to count how many people match the criteria. So we're going to need to divide by that to get the average. Then we'll have to have a running total of what their ages are. Right? Something like that. So we'd have to have like 2 throwaway variables. And again, I won't actually do it here, but we'd have to have 2 throwaway variables declared before this if statement, and it kind of zeroed out, or actually before the for loop, right, before the for loop. And then if the person matches, well, add 1 to the count and add their age to the total age. Right? And then after the for loop, well, perform the calculation. Right? So that's kind of a bulk data operation we want to be able to do, much more complex. Right? And again, just tons of examples for that. Printing the name like the example here, not too bad, but pretty quickly it can be pretty tough to do. All right. So how do we do this with this new collection stream API? All right. This is really pretty straightforward, right? We're going through everything. We're setting out some criteria for stuff that we basically want to filter out of the list of matches, and then we want to do something for all the matches, right? That is so common of a pattern. The question is, well, wouldn't it be great if Java could help me do that for me, right? Well, guess what? With collection stream API, that's what we've got, right? What we do is we create a stream, basically, of the data coming out. Right? Notice here a key part to this code is we take the variable to refer to the list in the collection, in this case, when we call the stream method. Basically call the stream method. And now we supply our conditions. Right? And this is using method chaining. Hopefully everybody's familiar with method chaining. The idea is I have lots of methods that I'm calling back to back on each other, mainly because the output of all of these filter methods is another stream. It is a stream of all of the things it matches. So with the stream API, you can apply all these intermediate functions. And these intermediate functions are, in this case, filtering out what's going to be part of this match. Right? So we're filtering out what's part of this match. And now it's a lot easier to provide the conditions. And notice the conditions are supplied as Lambda expressions. Right? So, this is, again, another big impact of Lambda expressions is now we have this ability to do something like this because it's very easy to pass in as an object, in this case, some condition, and some test that we can perform to say, well, should this, match this filter or not, right? So any object, any person that has an age less than 45, well, they get filtered out. Right? They wouldn't make it past this for a filter. Anybody that has an age over 45, well, they're still in the possible group, right? So get gender male, state equals California. Again, not too much difference there between the expression we had before. Just we're doing method chaining instead of having that multiple and situation within the if statement, right? But notice here now for each. Right? So now we say, okay, well, this is the new method that's been added to a stream. You basically say, well, in each thing that matches all of these criteria, we basically filtered out everything that doesn't match, what do we want to do? Well, in this case, we want to, again, just print the name. Okay? Something like that. A little bit easier to read. Okay? A little bit easier to read, certainly a little bit easier to look for the conditions. Right? So something like that. Somebody asked, and logic or logic. Don't have an answer to that off the top of my head. Filter is basically anything that doesn't match will be ignored. For the Lambda expression, though, you could have a Lambda expression that does have or logic as well, right? So these are fairly simple expressions where we're just looking at one property, right? So we're basically doing that. But yeah, you could have a Lambda expression that has that or logic as part of it. And there's some other functional interfaces that are part of Lambda as well, or that are part of the. There's a function package basically. Right? So there's part of this as well. So that would be part of. So that would be probably part of Lambda expression. All right. I don't think I actually mentioned it in the webinar, but somebody just asked a question about performance. All right. Big difference with performance in terms of how this is. Oops. Is that coming through, guys? Okay. I think I'm still on. Okay. But in terms of performance, right? One of the big things that's becoming more and more common, of course, is running Java code in a environment that has, let's say, multiple processors, right? And doing things in parallel, right? Doing this without the stream API, And again, if you look at some of the some of the sessions that were in the Java 8 launch from Oracle, there's a good discussion of this. But if we're doing it without the Stream API, doing something in parallel is fairly tough to do. You've got to do it all on your own, and the code changes quite a bit. Right? If I wanted to do this in parallel and basically do all of this with same thing but do it in parallel, guess what changes? Only thing that changes is up here. Instead of just stream, I just say parallel stream. Right? That's it. Okay? And then the library says, oh, okay, you want to do that in parallel? Well, I'll go ahead and do it in parallel, and I'll figure it out for you. Right? You're telling me all the things that I have to do. You're telling me all the things I have to filter out, and all the the action you want to take for each one. So I'll go ahead and figure out how to turn that into something that's parallel, right? Rather than us having to do it manually and write the code in a different way. Right? The library can do it itself. All right. And somebody said parallel means forking threads. Is that right? That's correct. That's correct. Basically, that will do kind of automatic concurrent programming. All you basically have to do is tell the Stream API that that's okay to do. Right? I think the reasoning is they didn't want it to happen automatically. Right? They did want to have you still have some control over it, but you want to have it to be a certainly you wanted to have still some control over it. So something like that. All right. I'm probably going to have to keep going. I don't think I'll have to be able to keep up with the questions, so let me go ahead and keep going so I can make sure I can get through everything. But again, even though the webinar doesn't mention, I will say that changing this from stream to parallel stream is all you need to do to turn it into a parallel algorithm. Right? Compared to the non-stream API method, again, a little bit of a nightmare to do something like that. All right. So going back to kind of the benefit of the Stream API, you might think, well, the difference between this and what we had before, right? Hey, no big deal, right? Here we've got a loop, we've got an if statement, and here we've got these filter methods, no big deal. But what about a search algorithm, right? What about we're implementing a search where the search criteria are passed in by a user? And it's fairly common to have maybe lots of different fields that you can fill in, but a lot of them are optional, right? So how do you implement a search when I could have anywhere between 0 to 10 conditions or something, right? Having logic like this, where it's in the expression that we have in an if statement, much tougher to do, right? But if I can just kind of automatically on the fly add those conditions when they're present, right, through this filter method, much easier. Right? Much easier to kind of implement that. Plus, it's a lot easier to see what's going on. It's a lot easier to see, well, if they supplied this search parameter, here's what I'm going to pass it in. I'm going to pass in whatever they passed in as one of the search criteria we're doing. Whereas if you were to try and do that in a just a single expression, real easy to perhaps make a mistake or have an issue where you forgot one of the conditions. Right? So again, that's one way where this could be a big deal. Again, what about not doing the name? Right? Won't even think about the non-stream API to do this, right? What about getting the average age? Right? Well, it's pretty simple, right? All we have to do, and really the only thing that changes is notice we're still doing the same filtering, but now we're saying, well, now I want to look at the ages, right? So rather than looking at the individual people, I want to map to the integer, which is the age. Say, okay, well, basically get all of that, and then create the average. Right? So these are built-in functions for doing these common kinds of data manipulations, averaging and summing and counting and all that kind of stuff built into the Stream API. So rather than having to declare our own variables and implement this, they basically just call the right methods in the Stream API and it does it for us. Right? Again, the idea is if you look at that pattern of how would I count stuff up and do an average, that pattern is always the same. Right? The only thing that really differs was what was I counting, right? What were the conditions for what I was counting? So really, with this API, you can focus on that. You can focus on what are my filters that I'm applying to say what's part of this thing that I'm counting or averaging, but it's just calling methods to actually get the data. So much simpler to do. All right. Much more complex example, right? What if we wanted to go through all of the people and we wanted to have them sorted alphabetically by name and grouped by the state? So we wanted all the people from California in one group, all the people from Arizona in one group, etc. You can imagine, pretty tough to do, right? Again, the stream API, really simple. Basically create a stream from those people. And notice we don't have any filters here, just because we're going to assume that it's everybody. Just kept a little bit simple, but you could apply filters as well. And now we have sorting, so we can apply sorting. Right? And basically you just tell it, well, what do I want to sort by? Well, sort by person get name. So again, this is that method reference. It tells it, here's a method you can use to do the sorting, right? And then I can collect it. There's a collectors class that's part of the stream API that'll collect it into a map. Right? And notice that map is going to be, the key is going to be a string, which will be the state, and then each value of each key is going to be a list of the people grouped by the state. Right? So all I have to do is say, well, call this collectors class grouping by the state. Right? So tell me, what should I use for the key to group things together into this, into this map, right? In this case, just the state, right? So if you think about what we're doing, and look at how well the code reads compared to the requirement for what we want to do, right? Really, you can read through the code and you can see pretty easily, hey, we're going to get a stream of people sorted by name, grouped by state, right? Pretty easy to tell that's what's going on. Whereas if we were trying to do this without the stream API, again, the more manual implementation of this, super easy to get lost. Right? And not only would it be hard for someone else coming in to figure out what's going on in like a maintenance situation, something like that, also easy to maybe make a mistake in how I've implemented it, and we're not grouping by the right thing or something like that. Really easy to do it here though, right? Really easy to do it here, and also change it quite a bit. All right, here is the collectors class inferring the return map from the declaration. It is, right? So notice here what we're returning. Again, let me erase some of this stuff. Right, we're returning something that's going to be a map of string, and really what it's inferring is what the state is. So get state returns a string, so it knows, okay, the key of this map that I'm creating is a string, right? What it's going to be determining how what the values of that are is the list that I'm working with. So here, notice people. Again, we don't have this actual line here, but the people is a list of person objects, right? So it says, well, if this starts out as a list of person objects, I'm still working with the list of person objects, that's what I'm going to collect. I'm going to collect those person objects grouped by get state as a string, so I'll group it by string. Right? So actually kind of ignore the declaration there. That just happens to match up. Most importantly, inferring by the type that we pass in a grouping by and the type of stream that we're using from, in this case, a stream of people, person objects. All right. Yeah, good question. All right. So again, method references, Lambda expressions, right? Basically, the being used here, but more importantly, is this new API, the stream API that we're being provided with, basically, to implement all these different things, all the different possibilities that you can do with the stream API. And this is probably one of the other big things that you're really going to see. All of those different requirements for, hey, we've got to do something with a set of data. Right? Really, the stream API is going to do a lot of stuff for you. All right. Again, I'll have to keep moving a little bit, try and get through everything before we run out of time too much. Another big thing, we'll talk about date and time. So a couple slides here with date and time. And then hopefully, like I said, I'll leave probably the Java 7 changes as reference. You guys get this. But we'll try and go back and hit some of the questions that haven't been answered if we can at the end. All right. So another big change, date and time. Now you might say, well, wait a second, right? What do you mean Java 8 has this date and time API? Haven't we always had date with Java? Sure, right? We've always had, Java util date, always had the idea of a date in Java, but some of the things that you want to do with dates and times have been difficult. Right? And we've relied on third-party libraries to do for us in the past. right? So JSR 3.10, which is one of the many Java specifications, was kind of rolled up into what was released with Java 8. JSR 3.10 says, you know what, let's expand what you can do with basically time calculations, like built-in calculations. For example, what if I want to add 2 months? What if I want to get the last day of a certain month? Something like that. You can also work with date and time types that exclude time zone or ones that include it. So depending on the context, do I want to have time zone included or not? Right? Kind of meant to replace date, calendar, time zone, date format classes from Java Util. And the big thing here is new package. Right? So we now have this new package for java.time, which has all of the classes and interfaces related to the date and time API. All right. So this one's a little bit more focused, certainly. Certainly if I'm not doing stuff with date and time stuff that I don't really care about this, unlike Lambda Expressions and Stream API, a little bit more broader impact of what it is, right? But pretty significant. Pretty significant, especially something that we've needed for a long time. Hey, let's add it into Java. Rather than relying on third-party libraries to give us this functionality, Java says, you know what, that should just be part of Java. Let's just expand what Java can do to address that a little bit more. All right. Up until now, we've had the date object in Java util.date, which represents both. It really represents a moment in time. It represents a date and a time together, right? Well, now in the JSR 3.10 date and time API, you can choose. Right? Do I only care about the date? Do I only care about the time? Think about, like storing somebody's birthday, right? Doing it with Java util.date, well, we better make sure that we're storing it at noon on that day or whatever. Well, the time really doesn't matter. It's the date that matters, your month and day. So now with the date and time API, we have a distinction, and you can do that. Key classes involved here. Notice we have local versions. Local simply means that we don't have time zone stored with this object, right? And notice you have local date, local time, and local date time. Right? So if you want to have just date, you have that. If you want to have just time, you have that. If you need both, well, you got both. So depending on the context, we can choose which object we want to use. Right? Time zones are now going to be handled separate. Right? Notice here we have zone date time. So it's basically a date time that has the idea of having a time zone added to it. This is the closest to what we had before with calendar, something like that. What we had before with date, right? Really, again, it represented kind of a moment in time, more accurately, right? And really just thinking about it as just date was kind of misleading. So now the new API, we have this object called instant. And instant is basically similar to date. Hey, I want to track this instant in time to do something with it. And I figured out, well, if I started now, and I was taking a 5-hour flight to another city, well, what would the time be when I got there? Something like that. So it gives you a lot more flexibility in what type you want to use depending on the context, depending on the application need. And again, so if we don't need time zone, we don't need to use time zone. If we want to have a moment in time, we can. If we want to have just the date, not worry about the time, you can do that. So again, one of the big things, you have choice. You have choice with this. All right. Oops, let me erase the drawings there. There's different classes, this local date class, local time class, etc. A lot of static methods for getting an instance, so you're not calling constructors, and you're basically calling a static method. So notice on the local date class, you do have a now method. So the now method basically says, well, give me a local date that represents, this date right now, basically. I can store that as a variable. There's also an of method. So of says, well, pass me in some parameters for the year, month, and day that you want to, basically create a data object for, and I'll construct a date from that. But notice these are all static methods on the local date class itself. Right? So I'm not calling a constructor, just calling a static method on the class. Right? Convenience methods for comparison. So there's things like isAfter. Right? Again, not built in to what we had before, right? So you'd have to do, maybe a less than, greater than, something like that, and you can kind of make some assumptions, but here we can basically have a method. So much easier to read the logic. Hey, date.is after birthday. Right? So is this date after the other parameter I'm passing into the method? It's a lot easier to read that, at the very least. All right. The objects themselves are immutable, so these things are immutable. What if I wanted to have a day that's been changed in some way? So notice next birthday, well, let me add a year. Right? Let me add a year to the current date, and let me come up with the next local date. Right? So it's going to be a new instance, basically, a new object with 1 year in the future from that day, from where this birthday bday variable refers to. Here, what if I want to say, well, 2 months minus 3 days? And again, there are basically methods built right into the API. Makes it real easy to read basically what you're doing. Right? And again, this is aware of the calendar and all that kind of stuff, so it's doing these calculations correctly, basically. So again, much easier to do. It's built into the API. You don't have to come up with some tricks or rely on a third-party library to do it. It's just part of the Java library itself. All right. More abstract things, saying 2 months in the future, and 3 days from now. That's pretty straightforward. That's not too bad. But more abstract things are a little bit hard. What about the last day of the month? Well, what month are we talking about? Right? So are we talking February or June or September? Right? That changes depending on the month. Right? What if I want to change a date to next Friday? Right? So, well, it depends on what day I'm at. Right? Well, wouldn't it be nice if I had a way of just saying, hey, change it to next Friday, and that would basically function the same way no matter where I was starting from. So I had to figure out, hey, I'm on a Tuesday, so that means 3 days or 10 days or whatever. Right? So there's a TemporalAdjusters class in the state and time API. Right? Tons of methods to make this easier. So notice here I can basically pass in, so here TemporalAdjusters, last day of month. So last day of month, thinking about right now, what's the last day of the month right now, and create a date, basically with that. And so basically a date from that, and also modify the date to say next Friday. So TemporalAdjusters, there's a next operation. Pass in this case, there's an enumeration of days of week, and pass in Friday. Right? So much easier to get. And we're writing code that's a little bit easier to read, written exactly like what we're trying to do, rather than figuring out, hey, how many days am I going to add? Right now it's Tuesday. Right now I've got to add 3 days to get to next Friday. Don't worry about that. Just, hey, tell me you want next Friday. So much easier, especially in terms of manipulating stuff. And all of these manipulations aware of, hey, we're in February. Now we've got fewer days. Or, hey, we're in June where we've got 30 or 31, whatever. Right? So that's part of it. All right. So again, a little bit more specific, definitely than Lambda Expressions and Stream API, but tons of functionality for anything that you have to do with date and time calculations. And because that is a fairly common thing that we have to do in a lot of different applications, definitely something to think about. All right. One thing I wanted to kind of mention, it talks about default methods here in a second, and I kind of played around with how to introduce this basically. The idea behind what we're going to talk about with default methods and static methods is we want to allow an interface to change. We want to allow an interface to evolve over time, but we're still thinking about backwards compatibility, right? And an example I had, we kind of think of the reverse, right? The reverse in Java, right? The reverse in Java has been deprecation, right? Deprecation, theoretically, is we're trying to remove stuff, right? We're trying to remove stuff from an interface, from a class. But when you think about deprecation in Java, to me it's almost kind of a joke sometimes, because I don't think there's really been stuff that has actually been removed, right? Well, why is that? If you think about that, the reason for that is it's one thing to give you like a compilation warning and say, hey, you know what, you could do this a different way, right? But, well, it'll still work. Right? We'll still let you run it. Actually removing something or actually adding something, much more significant change, right? So deprecation, that's why things generally has not actually been removed typically, because actually removing it would break the code. Same thing with new methods. Right? If I add a new method to an existing interface, right, I'd have the same problems. Any code that we had from that interface before would not compile anymore. It would not be correct. Right? It'd be great if we could just go back and update all of the other classes, but as we have more and more libraries, as we rely on more and more third-party libraries and this kind of stuff, it becomes harder and harder to do. Right? So that's the idea here. All right. If you think about what we're doing with Java 8, right? So many things of the Java API changed for things like Lambda Expressions. This became a very big problem. I said, you know what? This is really an issue. We're going to introduce a lot of changes to a lot of interfaces, and that's going to have a really big impact on existing libraries. Right? Well, what if we could introduce it in a way that would not break existing libraries? Right? So to solve this particular problem, and not only in the stuff they were introducing in Java 8, but stuff that you can introduce as well in your own Java interfaces, they introduced something called default methods. Sometimes you might hear these referred to as extension methods. The idea is we're taking an existing interface and we're adding something to it as an extension. So it's a little bit different. And we see kind of a little bit more about what's going on. The idea is we're extending an existing interface without breaking compatibility. Well, how can you do that? Right? With the standard definition of interfaces, you wouldn't be able to do that. Right? You add a new method. There's a class that says, hi, I implement an interface. Suddenly it's not correctly implementing the interface. Really what you need to be able to do is provide a new method with an implementation, unless that implementation is overridden by what is implementing the interface. Right? That's where this default method comes in. And it's default because notice the term here, we add the default keyword in front of the method declaration. Notice we are in an interface declaration. Right? Normally, interface declarations would always end with just a semicolon because they're all abstract methods. They're all methods that some other class that's going to implement this interface has to provide the implementation for. Well, now with default methods, notice instead of a semicolon, we have a set of curly brackets. Right? We actually have implementation code. Right? So this is very different than what we're used to in interfaces because we have this default method. Right? The idea is that if I have another class that implements this interface, right, if it does not provide its own implementation, in this case of this new method that I'm defining here, right, the default implementation defined in the interface directly is what would be used. Right? So a big change in really what you call an interface, these default methods. Right? So you have this default implementation, and really that's a good way to think about it. Think about it as, hey, this is a default implementation in the interface itself if the code doesn't provide its own. Right? Almost makes it kind of optional, because now the idea is, well, if that class doesn't provide this method, doesn't provide its own implementation of this method, then this one is what will be used. Right? It'll still be there. Right? So anything that is expecting that method to be there in an implementation of this interface, it will still get an implementation to call. It's just a question of, is this implementation being provided by the interface itself as the default, or is it being overridden and implemented by the class? Right? So it provides a little bit more flexibility, you might think. All right. So if a class implements the interface and provides an implementation of the method, the default one is ignored. And I would use the one that's defined in the class that's implementing the interface. Basically, it means that an interface with default methods becomes, in my mind, similar to an abstract class. Because remember, in an abstract class, we could do that thing. We could have some methods that were abstract and needed to be implemented by classes that extended that abstract class, or we could have methods that had an implementation. Right? The only difference, though, is that an interface still can't have fields. So we still can't have state. Right? We can have basically methods that are providing even an implementation, default implementation with the interface. Right? So really, in this case, you can kind of get a little bit of multiple inheritance, if you will, as far as functionality is concerned, as far as behavior is concerned, as far as methods are concerned. Right? So multiple interfaces can be implemented by a class, right? So that a class can still extend one abstract class. All right. I mentioned up here it's the default and static methods. In addition to default, you can also add the static declaration. Right, so just like if you had a static method in a class definition, now you can have the same thing in an interface. Right? Again, basically the idea here is you have implementation code. Right? So again, it's just like, this is one way to have a static utility method defined with implementation in the interface itself. Right? Is to have something like that. All right. So big change in terms of defining interfaces, and again, allowing interfaces to be a little bit more flexible, really, and add new stuff. And then as the classes that implement those interfaces realize, hey, you know what? There's a method. We don't necessarily have to implement it, but we can. Maybe now we provide our own implementation. All right. Until that class provides its own implementation, it can use the default from that interface. All right. Okay. All right, a couple miscellaneous things that I think we need to start wrapping up, I think. One of the things you might hear discussed with Java 8 is Nashorn JavaScript engine. Okay? Java 7 actually introduced the ability to invoke dynamic scripting languages from Java, but wasn't really used as much because it didn't provide an implementation. Now the Nashorn engine in Java 8 is an implementation of a JavaScript engine. Note that it is the JavaScript version 5.1. Okay? I just developed some material for us. Technically, JavaScript has gone to ECMA script 6 is out there now that was just released like last June or something. Nashorn is ECMA 5.1. Typically, is what you think of with JavaScript. It's what's been around for a while. But it's actually an implementation of a JavaScript engine. It's provided as part of the Java environment. Right? So it really opens up a lot of different possibilities. Now we can execute JavaScript from Java code, right, with the javax.script package, right? Pass data between the two. Kind of thinking from the other perspective, you can be writing JavaScript code and use Java syntax and APIs in that JavaScript code, and then get this engine to run, that JavaScript code because it's also aware of Java as well. Right? So a lot of different crossover kind of capabilities, basically. A lot of, finally, an integration we can really explore with this Java and JavaScript integration. Again, it's been there for a while. This hasn't been really as easy to use because you needed something else to really allow you to do that. Now they're providing basically an implementation of that with Java itself. So with Java 8 itself. If you look around in the bin directory of the Java installation, there's a new command called JJS. JJS basically runs this JavaScript engine from the command line, right? So this is what runs the Nashorn engine. All right, so interesting, again, not a lot of details, don't really have time to get into too much, but good thing to know about this integration between Java and JavaScript. All right. Tons of other stuff that really, in the interest of time, like I say, we get basically a one-line mention here, basically. It's not really, it has to do with the library itself, but one thing that I thought was good to mention is the Oracle, hotspot JRE basically has removed the permgen, basically, so it's not a separate location that it's going to move stuff into. So in the past, you had to, a lot of times you had to tune that and pass in a parameter when you're running your Java program to say, what's the size of the permgen and stuff. I actually removed that, so I don't have that space that's only for permanent objects anymore, basically. A couple things with annotations, right? Annotations before, if you wanted to have the same annotation more than once in a certain location, a lot of times what it had to do is you had to use like a plural version of that annotation that would wrap up several annotations, just because there was a restriction. Hey, you can only have one instance of a single annotation at a single location, right? So you kind of had to create this wrapper to have more than one. So they removed the you can have only one restriction. So now you can have multiple. So now we don't need those wrapper, plural annotations that wrap up multiple instances of an annotation. You can actually repeat annotations several times at the same location. Right? Again, different annotations has never been a problem. It's trying to use the exact same annotation at the exact same location. Before Java, you couldn't do that. So now you can. Type annotations, basically you can now use an annotation anywhere you can use a type. So this can be on a variable declaration. This can be, we've always had parameters, but kind of, parameters, just anywhere you could have the variable declared and associate a type with it, you could have an annotation. Right? Before it was a little restricted. We could have it on fields, but not like local variables within a method. Right? So that's one of the other things that's a little bit different now. Now we can have annotations. Anywhere you can have a type declaration, a type part. Compact profiles, right? Really just the idea that they're recognizing that applications do not always need all of Java SE. So kind of what Java ME did a long time ago, which was try to strip down the Java platform into smaller things for mobile devices. We're really now doing that in Java SE as well. And the idea that we can kind of have these smaller subsets of Java SE for lots of different devices. Right? It is not the same as Java ME. It's just kind of the same idea that we're kind of trying to strip down what we're requiring to be part of the environment. So the compact profile is just subsets of the Java SE specification, mainly meant to compact what we need to have on a particular device. Maybe it doesn't need everything that's part of Java SE. Right? Tons of security updates. Right? Most of these are not huge big things in terms of each one, but lots of different encryption algorithms that are possible. Higher bit encryption now available. I think 64-bit encryption in a lot of different places. So certainly if you write some code that has to do with encryption or any of the security APIs or anything like that, definitely go to the Java, what's new in Java 8 documentation and look through a lot of those. A lot of times it's more, this method now assumes this is the default, whereas before it did that. So a lot of times it's just kind of minor changes to make, kind of maybe different choices in terms of default security settings and stuff. So not a whole lot unless you're really doing a lot with encryption and algorithms and this kind of stuff. So take a look at that. JavaFX, right? Changes for that. We haven't seen as much kind of JavaFX really taking off. Some changes with that. Again, kind of minor parallel array sorting. So there's a new method that you can use to sort arrays in parallel. And again, built in the API. JDBC 4.2. So kind of minor revision of JDBC API. So again, a lot of kind of minor stuff, not really as broad or impactful as some of the other stuff we've seen, but some stuff to be aware of. And like I said, definitely go into the what's new in Java 8 documentation. I've got a link for it in this presentation, and look at that if you have interest in those specific areas. All right. What I'd like to do, let me open up the other poll real quick. Kind of start to wrap up. I'll see if I can go through some of the different questions as well. So the last poll is, what if you use Java Enterprise Application Servers? Right, basically, what Java Enterprise server you use? Again, just for us to get a little bit more, kind of information about what you guys can do. I think you can pick more than one on this. I realize I didn't double check that the other day, but I'm pretty sure you can check more than one. Let me see if I can go through a couple questions that we go through. Somebody asked a question, does the method chaining actually iterate over the collection n times for n filters? And the answer is actually no. And that's another good reason to perhaps use the method chaining and pass them in one condition at a time. It doesn't actually take action on that collection, or that stream in this case, until that last method. Until the last method where you're saying, count or something like that. Really all you're doing with the filter methods is you're just adding those conditions for what will match. Right? And then when it iterates internally, right, it will basically say, well, these are all the conditions that I have to match. Basically just like the one, the manual code we had. The manual code we had one if statement that had all of the conditions. We're only going through the list one time. Right? But I think what you're thinking is, you could do it the other way. Say, well, let me go through the list one time and eliminate everybody, under 45. Right? Then let me take that smaller list, iterate through it another time, and find all the males. And let me take that list, which is now, going to go through it a third time, and find all the people in California. It does not do that. So even though you have several filter methods that are specifying different conditions, right? It's only actually going to do the action with the last method. Right? So good question. Good question. All right. All right, let me go back through. Somebody asking about, is it synchronous? Again, the Stream API by default is synchronous. Again, you can do it in parallel and that kind of thing, but it's still, and I guess really parallel is a little different. It is still synchronous. It's still, hey, we're going to go through and do that calculation and come back to it. All right. So definitely do that. Yes, it's still synchronous. All right. Somebody asked a question of the slides again. In the follow-up email that should be going out, you guys should get a link for a copy of the slides, so that should be out there. So I'll put that in the email follow-up. All right. Well, it looks like everybody's voted is going to vote. So let me go ahead and close that. Just share that real quick. It looks like kind of what we expect. Usually we see more people with WebSphere in terms of number of clients. I don't know if that's just our clients or in general. I think overall, JBoss, WebLogic, some other, right? Interesting. The only 3% you don't use Java Enterprise. That's definitely, like I say, that's pretty common. Which Java Enterprise is one of the main applications of Java, I think, nowadays. So that's really why, again, I've kind of been waiting for focusing on Java 8 until probably this year, because now more application servers are going to be coming out with Java Enterprise 7 implementations. Again, all of them do have support for Java SE 8 if you're running some of the latest versions or something like that. So good kind of wait a little bit until people really need it. Right? Because like I say, 2 years ago we didn't really need to talk about Java 8 too much. Now more people are starting to use it, so more important. In terms of Java 8 courses, right? Again, when you guys have this presentation, when you download this from the email, the follow-up email, these are all links that you can follow directly to the course descriptions. We're also going to have a course map that's available, right? Because there's so many changes in Java 8, what we did, which we normally don't do, kind of a what's new class, but we decided to come up with kind of a what's new in Java 8 class. It's a 2-day class. And if you're already familiar with Java 7, and you've already been using a lot of Java in a lot of places, good place to focus on that. It's a shorter class, just focuses on what's new in Java 8, so to kind of update your current skills. Now, their advanced class, we have an advanced Java class basically. That's a longer class, but it also will include a lot of the stuff in Java 8 as well. Right? So a lot of the stuff like the Streams API and the Date and Time API and that kind of stuff, really it's stuff that you really have to kind of have some experience with Java before you can really dig into it. We also will have an Intro to Java class updated to Java 8 as well. So there will be some things there, but really the Intro to Java class is just getting familiar with writing classes and the syntax and the different expressions, the different operations you can have. So a lot of the more detailed APIs that are really added with Java 8, basically we've added those to the advanced Java class as well. Right? So it depends. If there are some things in the advanced Java class that you haven't been familiar with, you haven't seen, right? Definitely that would be a good one. But you don't necessarily need to take both the What's New class and the advanced Java class. It's kind of one or the other. Right? So we're changing that. All right. And again, these are links basically. We also have our Java 7 courses still, right? Kind of originally the plan was to just take the existing classes we had and just update them to Java 8, but kind of realize that we have people that are going to need Java 7 versions of those for a little while. Right? Maybe they're not using Java 8, they don't need to focus on that yet, so we'll have the Java 7 version as well. So we'll still have that if you need it. We have new courses, new course codes with Java 8. All right. Basically, this course map lays out all 5 of these. So I'll have a couple questions you can answer. Do you need Java 8 or not? Right? Are you experienced with Java? Do you need to just focus on Java 8 itself? Right? It'll help guide you towards kind of what classes are right. If you're new to Java, there is Intro to Java and then Advanced Java. That's typically our path we recommend. Really get you familiar with all of the different APIs that you're going to use in pretty much all Java applications you come across. And that's kind of the goal of both of those classes back to back. All right. We do have on the schedule for May a What's New in Java 8 course. So I'm going to run that in May 16th. I'm going to be teaching it right now. Again, there's a link that you can use to register here when you get these slides. Click on that. We also have some public Canadian classes on the schedule as well for April and May. And just some different cities there. Basically, if you go to the course description of $24.93, you should be able to find out when you can see that. But again, there's a virtual class we're running May 16th. So go ahead and register for that. And again, focusing just on what's new in Java 8. Right? So because there's a lot of shops out there that have a lot of Java experience, you don't have to go through even the advanced course a lot of times. You got to know half of that, just need what's new in Java 8. So because there's so much changes introduced in Java 8, I figured it was good to have a separate class to focus just on that. All right. So again, right, kind of moving forward again, obviously Oracle leading the way. Java SE 7 definitely more popular. See that, but basically the question we had, people are starting to use Java 8 either as the default for new projects or in some situations, so depending on that. And really lots of big changes in Java SE 8. And again, the Java SE 7 changes, I moved that to after the summary. I'll leave that as a reference because we're already over time. But if you do have any questions about the Java SE 7 stuff, go ahead and feel free to contact me. But changes in Java SE 8, probably the most since Java SE 5. And so it's been quite a while, about 10 years now, about 11 or 12, right? So quite a big changes. So a good time to focus and really see, well, exactly what's been happening. All right. In terms of contacts and different resources you might have, there's again my email. So you guys get this, you can go ahead and use that. Contact for us as a company. You need to contact us about working with training classes or anything like that. A couple things that are good Java resources. And especially there's the Java 8 launch event. Again, lots of good videos there. So if you want to focus on that, you have. Certainly the API technical documentation. And also there's a page, What's New in Java 8. So as part of the documentation, a little bit more complex URL. I wanted to include that just so that you guys can use that. Again, if you want a list of, this is all of the stuff that's different, that'd be a good list to use, especially if you're interested in like the security changes or some of the stuff we didn't really get as much into. A good place to start is there and see if they have additional links you can follow and get some more additional information. All right. All right. Well, that's it for the webinar. I'll go ahead and go back and try and see if I can pick up a couple of those questions. But if not, again, you guys will get the presentation in a follow-up email. All right. So basically that's what we have. Somebody asked a question, how do you pass a parameter to a Lambda expression? Actually, the first part of the Lambda expression are the parameters that are being passed in. So what's before that arrow, right, that is the parameters. So let's see if I can answer that question there. All right, and somebody asked, parallel. Again, I'm talking about the stream API and doing it as a parallel stream. Parallel means forking threads. So yes, so that's what we're doing there. Somebody asked, so it could have negative impact too. I'm not sure what that was about. I think that might have been for the stream API. So we're talking about the stream API, maybe our parallel discussion. All right, so I'm not sure about that. Somebody asked also about the date format. There is ability at the time, the Java time package for formatting those objects as well. So didn't really get into that. Couldn't really get into that, but there is that as well. All right. So the object Lambda is passed to passes the actual arguments, and that's correct. All right. So really, all you're doing in the Lambda expression is declaring, here are the parameters that would be passed in when this Lambda expression is used. So that's correct. So if we go back to our example of the Lambda example, right? All I'm doing here is I'm just saying that this Lambda expression is going to have coming in a P1 and P2, which will be two-person objects. Right? Notice that P1 and P2 in this case are not actual objects that are in this code anywhere. So it's not like we're passing in specific person objects. We're just kind of putting them as a placeholder, saying, hey, in order to use this Lambda expression, you need to call it with 2 person objects being passed as parameters. And then that's going to be used within the implementation code. Right? In fact, one thing that you'll see that's common with Lambda expressions is these parameters, the variables used for them are temporary variables. And you actually want them to be different than other variables you've already declared, not because it really makes any difference to begin with, but if you use a different variable name, it's going to be clear that, hey, this is not an existing object. And I'm not like calling a method with specific objects being passed in. I'm just kind of declaring in a method signature kind of these placeholders for, hey, these are 2 things that are going to be passed in. Right? So, we don't see a lot of the sample code here, but P1 and P2, these are not variables that were declared anywhere up here. Right? These are completely new temporary variables just for the Lambda expression. So we can use P1 and P2 within the expression of how do we do the compare to in this case. So yeah, good question. All right. So let me go back to the overview. I think we've done most of the questions. So if you guys do have any questions, feel free to put in the questions section. Otherwise, again, guys, thank you very much for the webinar, and we'll see you guys maybe at the next one. All right, guys, this is Stuart. Doesn't sound like we have any more questions, so I'll go ahead and shut down the webinar. And again, we'll see you guys at the next one. Have a good day. Bye.